So yesterday we talked about shape. We talked a little bit about stem and leaf plots and dot plots and figuring out shape from those. Today we're going to finish the center and spread part. You always want to report shape, center, and spread, and then give any unusual features like outliers and gaps. Okay? So we've done the shape part, so let's focus on the center part. Well, one easy way to measure the center is the median, right? To find the median, I'm not changing the definition of that. The median is still literally the center. So you put all of your data in order, and then you find the number in the middle. There's two values in the middle. You find the average of those two values, right? You're splitting the data in half, okay? So here is a histogram with the magnitude of some earthquakes that caused tsunamis from 1981 to 2005. So it has purple and yellow because they found that the median was 7 on the Richter scale, and you can see that it kind of splits the data in half. Okay? So the median is a definite measure of center. You want to make sure when you're reporting the median, we always need to practice putting things into context. So you want to report the median including units. So in this case, remember I said it was 7 on the Richter scale. If it's in milligrams, you put milligrams. If it's beats per minute, it's beats per minute. Whatever you're using, you need to make sure you include units. That ensures that you're hitting the context piece of the question, okay? So when you report a measure of center, you also have to report a measure of spread. You want to report how spread apart the data are, okay? So the easiest way to measure spread is range, okay? Now, the range, just like in middle school, is the maximum value minus the minimum value. So it's important to understand that, and there's going to be several times this year we talk about this, it's important to understand that the way we use the word range in the English language is not the way to report range in statistics. In the English language, we should normally say range, and then we give an interval of values. We say that something ranges from 4 inches to 7 inches. Or it ranges from 100 pounds to 120 pounds. In statistics, the range is a difference, the maximum minus the minimum, so it's a single number, not an interval of values. So make sure if you're talking about range, we want to talk about a single number, all right? Now, the problem with range, if you go back here and look at our tsunami data, a lot of the data is in this group here, but then you have an earthquake over here, and you got some over here, and you got one way down here, right? So if you're going to report the range, then you're going to take whatever this value is and subtract whatever that value is and give me a number. Well, that makes it seem like everything's way more spread apart than it really is, okay? Everything is actually closer to the center, so that's 7. Those just happen to be 2 outliers. So range is not generally what we use to measure spread. Instead, we use the interquartile range. Now, this is generally new information, so we'll talk about it. There is a lower quartile and an upper quartile in each set of data. The lower quartile we call the first quartile, or Q1. And the upper quartile we call the third quartile, or Q3, okay? Now these quartiles, what they do is when you take the median, or we need to start the median, you find the median, and that splits the data into 2 halves. Well, the quartiles split those halves into halves, so what you do is you end up splitting your data into fourths, okay? So the first quartile is the quote-unquote median of the first half of the data. And the third quartile, or upper quartile, is quote-unquote the median of the second half of the data, all right? Well, the IQR, or the interquartile range, is the upper quartile minus the lower quartile. So instead of subtracting the maximum value minus the minimum value, you're subtracting the quartiles. And since the quartiles are splitting the data into fourths, then each quartile beneath each quartile contains 25% of the data. So if you're doing the IQR, the upper quartile minus the lower, that's the middle 50%. right? The middle 50% should be more indicative of what's happening than the range. So if I go back to my tsunami data, I don't know for sure, this is just me estimating, but Q1 is probably somewhere in here, and Q3 is probably somewhere in here. And so if we subtract, we're just going to get this distance instead of all the way from the maximum to the minimum. And most of the data is within that IQR, the middle 50% there, right? So it makes a lot more sense. And you have the middle 50 showing how spread apart things are instead of the entire range of the data set. Okay. So, in order to practice, just because normally we haven't done this, so we want to make sure you know what you're talking about. We're going to find the median and the quartiles, and we call those measures of position because the median is in the center and the quartiles are in the center of each half, okay? Those don't change if you change the highest number to a different number. It doesn't change the median, all right? So, first thing we're going to do is put these in order. So 36, 40, 42, 48, 50, 56, 60, and 62. All right. First thing we're going to do is find the median. So there's 8 numbers in the data set, so the median would be splitting this in half. The median is going to be 49. So 50% of the data lies on each side of the median. Looking at this first half of the data, to find the first quartile, you find the middle of the first half. Well, there's 2 numbers in the middle. So the first quartile is 41, right? So now 25% of the data is here, and then 25% of the data is here. The third quartile is the top part of the data. Third quartile is going to be 58. Another 25% and 25%, right? We're splitting it into fourths. So to find the IQR then, you take 58 and subtract 41, and you get 17. So the middle 50% of the data is with 17 units of each other. Okay? That's what the IQR is reporting. So the middle 50% of the data is within 17 units. Okay? Does that make sense about median and quartiles and the IQR? Now your calculator will do all that for you. I wanted to make sure that we knew the kind of basics on our own. There word is the 5-number summary. The 5-number summary means these 5 measures: the minimum, the first quartile, the median, the third quartile, and the maximum. You can do this on your calculator and it actually gives you the 5-number summary, but it's important to know what the 5 different statistics are that you're going to use in your summary. So minimum, maximum, the quartiles, and the median. Now, we can use median and we can use IQR to talk about center and spread, but we can also use another measure of center. So another measure of center is the mean. We don't know how to find the mean, it's just an average, right? Don't let the formula on here trick you, it's just an average. I put this on here though because you need to know the notation. Anytime you have a bar over top of a variable, it's the mean. You can use whatever variable you really want, but if it has a bar over top, then we're talking about the mean. So we call this Y bar. Our book is going to use Y bar. Your calculator is going to use X bar. That's just the mean. So this is just telling you that they're adding up all the different data values and dividing by n. That's how you find the average. That's not a surprise. You know how to find an average. Your calculator can find an average. So it shouldn't be a big deal. But you do need to know the notation. It drives me crazy when we talk about this all the time, and then second semester someone is still asking me, what is the number with the bar? All right? X bar, Y bar is the mean. Now, is it important to use the mean or the median? Which one's better? Well, it kind of depends on what the distribution looks like. If your distribution is symmetric, It makes kind of like a bell curve, unimodal and symmetric. So pretty. You want to use the mean. Okay, the center of the data should be pretty much the same as the average of the data. If you have skewed data, however, you want to use the median, because the median will be in the literal center of the data, whereas the mean could be pulled up or down by the tail of the data. Okay? So if there's skewness, then any of those outliers and the things in the tail are going to affect the calculation of the mean. So you want to use the median instead. We say that the median is resistant to outliers, all right? Because we're not looking for a specific average or anything. We're just finding the actual center of the data set. So we say it's resistant. So symmetric will be mean, skewed will be median, okay? Now, we talked about the IQR for the spread, but there's also something called the standard deviation. Now, why do I keep giving you new measures of center and spread? Well, because they're package deals, all right? So, quickly, to sum up before we really talk about the standard deviation. When you have skewed data, you use the median to describe center, and you use the IQR to describe spread. That's a package deal. These come together, all right? If you have symmetric data, you're going to use the mean and the standard deviation, which we're going to talk about. Again, that's a package deal. They go together, all right? So it's not optional. And lots of the homework questions tonight are going to ask you which summary statistics you're going to use. Well, those are your summary statistics. You have two options and no more than that. Okay? So let's talk about standard deviation. Now, the standard deviation, it's an estimate for how far each data point is on average from the mean. Right? How far is each data point on average from the mean? That tells you how spread apart the data is. If on average every data point is within 1 unit of the mean, then that means that most of the data is pretty close together. If on average every data point is 15 units away from the mean, then that's a little more spread out. Or if it's on average 50 units away from the mean, that's pretty spread out. Okay? That's why we can only use this as symmetric data. If it's skewed, this won't work. Remember, because the mean gets affected and the standard deviation will be affected as well. So, this is how they do this. All right, I'll show you the formula. What they do is they take each data value. So y is a data value. All right? They subtract the mean. So if the mean is affected, the standard deviation will be affected as well because it's calculated based on the mean. So you find the difference between a data point and the mean. All right? What they would like to do is add those all together, hence the sigma. But if you're thinking about symmetric data, which is what we're using this for, then you're going to have some positive differences and some negative differences on each side of the mean. So if you just took all those differences and added them all together, they would cancel each other out. Some would be positive, some would be negative. So in order to fix that, they square all those differences first and then add them all together. Then they're going to divide by n minus 1, not n. So it's not a direct average of that sum. But we will talk about that later in the book. Right? Even the authors tell you in this chapter, it's kind of there, and you'll have to deal with it, and we'll talk more about it. Okay? So, and after they do all that, they take the square root because they squared in the middle, right? And that gives you S, the standard deviation. This formula is on the formula sheet, on your AP formula sheet. However, I don't have time for that. I don't know if you have time for that. If you have 60 numbers in a data set, I do not have time to take every single number, subtract the mean from it, square it, then keep track of all of those differences and add them all together and divide by n minus 1 and then take the square root. You don't have time to do that on an AP test either, all right? So we're going to rely on our calculator to do that for us, all right? So Here are some things to help you with standard deviation. If you're looking at a data set, you want to look at the mean. You want to see how far everything is away from the mean, so it's always based on the mean. And if you're looking at a picture, a histogram or a stem plot, this should help with some of the homework problems. About 70% of the data should be within one standard deviation. Now, that's because that's plus and minus from the mean. So if I said that the mean of the data set, I said X bar was 50, the standard deviation is 12. Okay? Well, that means I'm looking at numbers from 38 to 62. All right? This is plus 1 standard deviation. This is minus 1 standard deviation. All right? So we're looking at both sides. Again, standard deviation is the typical amount that each data point is away from the mean. Okay? And we will talk way more about standard deviation in chapter 6. We're kind of getting our feet wet about the fact that we report that with the mean. So again, the biggest part of this is that we want to make sure to use the mean and standard deviation for symmetric data and the median and IQR for skewed data. Okay? So let's do an example or two, and then I'll let you do the assignment. So it says the histogram shows the lengths of the hospital stays in days for all the female patients admitted to hospitals in New York during 1 year with a primary diagnosis of heart attack. So there's the histogram. And it says from the histogram, would you expect the mean or median to be larger? Now, this is unimodal and skewed to the right. Remember, there's people all the way down here. And so because it's skewed to the right, it pulls the mean in this direction. It doesn't mean the mean is way up here at the tail. I'm just saying that if it was symmetric, the median and mean would be about the same place. But since there's this tail, it's pulling the mean up. So because of that, I would expect the mean to be larger, all right, because of the skewness. If the tail went the other direction, then I would expect the tail to pull the mean down, okay? So keep that in mind. I don't know how much it's going to pull it down. I don't have the exact data. I don't know how much it's going to pull it up. But I just know that because of that tail and that skewness, you're going to cause one measure to be larger than the other. Now it's just to write a few sentences describing the distribution. So we want to write in complete sentences. I'm not going to for sake of time right now. But we would say the shape is unimodal and skewed to the right. Someone asked me in another class if it would be bimodal because of this bar. That's a good question. Remember, a mode is a group of data. In this case, you have one bar by itself. That's not really a group of data. It just so happens that there are a lot of people that have a heart attack that aren't in the hospital very long because they're minor heart attacks. Okay, so that's all those people that were released within about 1 day. All right, if we're going to talk about the center and spread, we can make some estimates. We can say the center might be at about, I don't know, 7 days. We can give the spread. We can talk about the range if you want to. We can talk about the IQR. It seems that the IQR is probably somewhere within here, right? So spread of about 7 days. These are estimates. I'm completely eyeballing those things, okay? And unusual features, there seems to be some very high, well, I guess not high, very long hospital stays from the skewness. So I again would write that in some complete sentences, just describing the shape, the center, and the spread. Now C says, which summary statistics would you choose to summarize the center and spread in these data and why? So that's asking you, do you use the mean and standard deviation, or do you use the median and IQR? That's the question it's asking, and that's all based on the shape. Because of skewness, so because of the skewness. I would use the median and IQR. If it was symmetric, it would be mean and standard deviation. All right. One more question. For each lettered part, A through C, examine the two given sets of numbers without doing any calculations. Decide which set has the larger standard deviation and explain why. Then check by finding the standard deviations by hand. Well, I'm not doing those by hand. We already talked about that. But here's the deal. So let's look at A. We're not doing any calculations. We're just going to be looking at them. If we're eyeballing this, looks like the center of this data set is 6, and the center of this data set is 6, right? Because you have some odds with the 6 in the middle, you have the evens with the 6 in the middle, so it's probably the mean of both data sets. If I'm trying to figure out which one has a larger standard deviation, I want to know which one's farther apart, which one is more spread apart. So if I look at 3, 5, 6, 7, 9 as a data set, well, I'm 1 away from the center, 1 away, and then this is 3, and this is 3, right? This is a distance of 2, if you want to think of it that way. If I look at 2, 4, 6, 8, 10, well, this is 2, and that's 2. And this is a distance of 4, and that's a distance of 4, and that's a distance of 2. So it seems like set 1 is closer together. Right? Standard deviation is the measure of spread. So closer together. And so since it's closer together, then you have a smaller standard deviation because it's closer. And we think this one's going to have a larger standard deviation. Okay? So this is a great time to talk about how to do all these statistics in your calculator. I keep saying you can do it, but I haven't showed you how. So we'll do it right now. So in order to find all the stuff in your calculator, the first thing you need to know is how to enter data into your calculator. So you go to Stat, and you click the number 1, Edit. Okay? Now you probably don't have anything in your list. I'm going to go ahead and put this first set in the calculator. So 3, 5, 6, 7, 9. All right? Then you can hit second quit, and you're out of your list. Now I want to show you a few things. If you don't need this data anymore, and we're going to be using lots of data in here, so you won't need it all the time. If you won't be using this data anymore, you go and highlight the top title where it says L1, and you hit clear, and then you hit enter, and it all goes away. Now, most of you will be tempted to go up here and hit the delete button. But when you hit the delete button, the entire list goes away, right? Look at the title. I have L2, L3, L4, and I can't get to L1. It's not there. Okay? So, we need to bring it back. So you go to Stat. You go down to the 5 where it says Setup Editor. You hit enter, and hit enter again. It says Done. And then we go to Stat, go back to Edit, and your list is back with the numbers in it. Okay? So you don't want to delete your list. You want to clear the list. Okay? All right. So once you have a list on there, then you can do some stuff with it. So tomorrow we'll talk about how to make a histogram with the information in your list. Today we're going to talk about how to find all those summary statistics. So you go back to Stat, and this time you scroll over to Calc. You go One Variable Statistics. On your list, we'll put whatever list it's in. So, of course, my information is in list 1. If you're keeping track of lots of data, maybe it's in list 2 or list 3. To change the list, you just hit second, and then that number gives you the list. But again, ours is all in list 1, hopefully. We'll talk about frequency lists tomorrow. Pretty much that just gives you a way, if you have a survey and there's only 5 possible answers, there's only 5 data values, but you gave it to 200 people. And instead of typing in 200 numbers, then you can type in the 5 data values in list 1, and then in list 2, you can list how many of each there are, okay? So we'll talk about that a little bit more tomorrow. You scroll down and hit Calculate, and now I have some information. X bar is the mean. So the mean was 6, like we talked about. Sx is the standard deviation. So for this set, I have a standard deviation of 2.24. That's good to know. Now, we're going to finish this problem in a second, but if you scroll down, let's see here, n equals 5 tells you how many data values there were. So there were 5 data values. And if you see there's a flashing cursor and there's an arrow, so if you scroll down, you get the 5-number summary. You get the minimum value, Q1, median, Q3, and the maximum value. Okay? So that's all available in your calculator. If you wanted to find the IQR, you could subtract 8 minus 4 and get 4, right? If you wanted the range, you do 9 minus 3 and get 6. All right, so all of that is available to you in your calculator. So let's look at the second set. So the first set had a standard deviation of 2.24, and we said it should be smaller. So if we're going to the second set, I can go back to Stat, Edit, and this time I can change my list. I can clear it, not delete it, and put 2, 4, 6, 8, 10 in there. And then I can Stat, Calc, one variable statistics. I put it all in list 1. Says the mean was 6, but this time the standard deviation was 3.16. So we've confirmed that the standard deviation was larger in the second set. All right. Hopefully that kind of helps you about standard deviation. So I know I've covered a lot of things, and there's going to be a lengthy homework assignment. But then tomorrow we can talk about anything that's still lingering. Hopefully you can work through some of this and start to make sense of some of these things. All right. Just remember that when you're talking about summary statistics, median and IQR are a package deal, and the mean and standard deviation are a package deal. Okay? All right.